This is a simple tutorial on how to update or install Marlin firmware into your 3D printer controller board. We're going to begin by grabbing the things we actually need to download. You can go right to, if your board is an Arduino board or an Arduino based board, you can go right to Arduino's website and download the latest version of their installer. As you install it, it's going to pretty much include everything you need. It's going to include the software, the USB driver, and it's going to automatically associate, create desktop shortcuts, blah, 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 blah. It's going to take care of everything you pretty much need for it. You could stop there and just download this to do the whole entire editing that you need to, but I'm going to show you a couple of other options to play around with also. So while that's installing, do yourself a favor, go over, just Google Marlin Firmware 3D printer. It should take you right to the GitHub for the Marlin Firmware. As of February 8th, 2016, the latest version is 1.1.0 RC3. You can just download that whole entire zip. I downloaded it already and extracted it right to my desktop. While that's going, if you really want to go to some of the other options, you can also download Notepad++. It's very simple to use. It's free. All the software that I'm showing here is free. You don't have to pay for anything. But Notepad++ comes in real handy later on as I show you more than one way to skin a cat, per se. So I'm going to go ahead and close this out. That's still downloading. You can grab the links right off the screenshots, or you can just Google them, real simple. Arduino software, Marlin firmware on GitHub, and Notepad++. We're not going to need the browser, so let's close that out. This is still installing. So your Marlin firmware will come zipped up in a nice little zip folder. You can extract that, put that right on your desktop or wherever you like to keep it. Just have it ready. We're going to need that. You can also, my suggestion to you, that was the installer right there. My suggestion to you is do it twice. Make 2 folders of it, because we're going to be playing in here pretty heavily. You're going to lose yourself real quickly. So I like to always keep an original one on hand, and I like to keep a second one that I play with. So, and this is the one we're going to concentrate and play with. When you double click the folder structure will show up, so you'll see how they did everything that they needed to, but all we're looking for is we're looking just for the Marlin folder. This is pretty much the only thing you actually need, is everything that's inside this folder. If you go ahead and double click the marlin.ino file, it will automatically open it up in Arduino, and you can see there, you can pretty much do all the editing and everything you need to do in the software in here. You don't necessarily have to go any further, but we're going to show you a couple of different ways of doing it. So what Marlin does, what Marlin does, it has all these little files over here are little text files. All it is just text files. You can go in here, edit each one that you need to, however you want to do this, or up here they'll have all the tabs for the designations. That they all are pretty much the same exact thing. So if you see like configuration H up here in this tab, it's the same thing as configuration H right here in the text file. This just organizes it all for you. It has it defined in different colors, everything else. If you want to do a lot of editing and you want to do it really quick, you can also do this in Notepad++, and this is even better. It gives you line numbers. If you're conference calling with somebody and you want to share information, you can go, hey, listen, I have a problem over at line 305. I don't know why you'd have a problem there, but I have a problem over at line 322. I don't understand what it means. So That's the beautiful thing about Notepad++. On the same exact side, it also has all these different colors. So you can quickly scan through a file and see what's turned on and what's turned off. So right now, by default, the colors are the way you see them in the screen right now. So anything that's brown is on, anything that's green is off. And if you highlight over a link, it turns blue, so you can click on it and open your browser. You can do it through Notepad++, or you can go right here in Configuration H. Again, they've gotten a little bit better with the Arduino interface, and they now have colors also included. And you can scroll through, you can see that things are turned on, things aren't turned on. So that's two different ways of doing it. You can actually open this in WordPad if you really, really want to, and you really want to suffer. You can do it in WordPad. However, this is horrible because you can't really, there's no color definition, and that's the advantage of Notepad++, or actually even the Arduino interface itself, is the advantage of being able to have all those colors to be able to edit whatever you want to. Well, you can edit whatever you want to, but to designate what's different, what's turned on, and what's turned off. So I don't suggest WordPad, but if you do it and you successfully do it, thumbs up to you. You're a braver person than I am. So you got your printer. You want to update your firmware, or you just got your printer, you want to upload some firmware. So all the files that are in here are pretty much all set. They have gone through every single update that have made this easier and easier and easier. The only file you really, really need to play with at any point in time, unless you're getting really advanced, is configuration.h file. I don't know why they call it .h, but you can, I don't know. You can ask them. But this is the file we're going to play with. I'm going to actually play with it in Notepad because it's just so much easier to use. So you see I got a couple of them open already. So I'm going to go through all the little stupid settings that are in here that are turned on, or that you should turn on, or you shouldn't turn on. So let's start up top. Define configuration H, blah, blah, blah. Scroll down. String configuration H author. So this is where you can write in your name if you're the guy that edited it, or you want to, define when you did it. I usually write down my name in here, and I just really just go and I usually put the date. I'm in the US, for those guys that are wondering why my numbers are all backwards. It's actually February 8th, 2016. So that's what I usually do, so I know the last time I configured it. Shows the boot screen. If you have an LCD, you might want this. If you don't have an LCD, this really doesn't matter, but you can leave it turned on. It doesn't hurt anything. Splash line, same thing, uselessness. Serial port. This is going to be the serial port on your controller. Most of your controllers that you have out there are going to be on serial port 0. This only matters, all this firmware is just for the actual printer when it's up and running. This is not for Windows or Linux or whatever you're using trying to communicate to the board. This is just for the board itself. So usually you don't have to change the serial port number. You can change the baud rate. Some boards support faster baud rates than others. Pretty much anything on a Mega, an Arduino Mega, or clones of the Arduino Mega can handle 2500 baud. But if you really want to play it safe, you can always just default to 115200. And that pretty much covers 90% of the controller boards out there. But like I said, if you know for a fact that your controller board can handle 2500, you can push it at 2500. It just helps out. If your controller board has Bluetooth, feel free to turn it on. Right now, and we're not going to show any of the Bluetooth stuff. Very few boards have it, and the boards that do have it usually involve soldering and to add it on, so I'm not even bothering with that. So the beautiful thing that they've done so far with Marlin is that they've started designating different boards. So if you really want to, there used to be a list in here of all the boards that they used to support, but you can pretty much look at the configuration inside of the file folder. You'll see like all these boards are now actually segregating each board individually instead of just keeping a large pins file. But you can still go into pins.h. Oh, that's the other beautiful thing about Notepad++. It just opens a tab right next to it. But you can go through, it'll tell you, you know, which board to include. I'm going to concentrate on the ramps boards because they're the most common ones out there. So here's one. So if I was to change in this, define motherboard, board ramps 13 EFB. Ramps 13 EFB. So that's going to automatically call that one. But I could change it to EEB, EFF. You know, I can, anytime I want to just change it to a different board, all I do is copy and paste. Yeah, didn't paste very cleanly. Whatever. So when that goes to, actually, it should be this one. Nope. No, I got that right. So when it goes to read that, it'll automatically add that file to it right here. So everything in these lines from this hashtag down is going to be, if you call either one of these boards, it'll automatically add all this stuff right to it. So back to the configuration H file. I'm actually going to undo that. Another beautiful feature of Notepad++. Anytime you screw up, you can just undo. We're going to keep going down. If you have a nickname for your printer, please feel free to add it right here. If you really want to go, if you really want to, you know, have it display on an LCD, or I don't know why you really name it if you didn't have an LCD. Maybe you have 12 printers and they're all on Bluetooth. I don't know. You can go even further. There's a reason for this machine UUID, and you're able to, you know, if you have a farm, you can literally have these all communicating on a network, and you have each one have its own serial number. Or if you're a person that's building 3D printers to sell, you can actually upload firmware with each serial number right to it. Beautiful thing right here if you build them. The number of extruders, I believe that it only handles up to 4 according to what it says right here. But most people either have 1 extruder, well, you have to have at least 1. So most people either have 1 extruder or 2 extruders. It will automatically add the pin configuration for the second extruder if your board is defined correctly. So for us with the ramps, board, if you change it to 2 extruders, it knows exactly what the pin assignment is for the second extruder. Now, if I try to do this with 4 extruders on the ramps board, later on when I go to compile, it's going to give me an error that it doesn't exist. So we're going to leave that at 1 or 2 if you have 2 extruders. Keep going down. This is where you start defining. So if you had 2 extruders right here, and you know that there's an offset between the 2 nozzles, this is where you could define it. For example, in X, why does it have 2? 2 values. Shouldn't have 2, just 1. So I know for a fact on my dual extruder machine, I have a 34mm offset in the X for both nozzles. But most slicers will handle that for you, so you don't even need to worry about that. Oh, and by the way, to turn a comment into a command, all you do is get rid of the 2 slashes, or to turn something off, all you gotta do is put the 2 slashes back on there. So that should be pretty easy. So if I was to actually put that into firmware, I would do this. Minor 34mm offset with a 0 offset for the Y. But I'm not turning that on. Some of this stuff I won't cover because it's a little bit more advanced, like the PSU stuff, how to turn it off. There's actually commands to actually tell you how to turn it off. So you can actually put it right in your G code as you print that at the end of it, it turns the power off, and it will automatically turn the power supply off if your power supply or your controller board has that option. Alright, now we're going to get into a little bit more of the interesting stuff. If you already have a 3D printer and the manufacturer has a firmware already for it, but you're trying to update it or get an extra piece of functionality because they haven't kept it up to date, you might want to have that handy. I actually have a copy of my original one for my RigidBot right here. So I'm going to show you a lot of the things that I'm going to import in. So here's a list of all your thermistors that are out there in the market that they know of without getting too crazy and including 16 pages of it. So these are the most common ones that are out there. So in this section, we're going to define temperature sensors. These are your thermistors. So sensor 1 would be your extruder. So here's your first extruder, your second extruder, your third, your fourth. So we told it we have 2 extruders. So, and I know the value of my extruder because of my original firmware is the type of extruder is an EEPROM 100K. So in here, I would tell it that that extruder is this one right here, number 1. If you have E3D hot ends, most of them are number 5 right here. Even though it's the same resistance between the two, you can probably leave it as a 1, but try to be as specific as possible. Eliminate errors that you could try to trace down later. So both my extruders are number 1. I don't have a third extruder or a fourth. My bed sensor is also somewhere on this list. And according to my manufacturer, it was also the same exact thermistor, type of thermistor. So that becomes a 1 also. So these actually have, the firmware has built in, so you can actually have 2 thermistors on a hot end. I guess the reason behind it, in case you do massive production runs on these things. I don't know why you'd have a 3D printer at home and be watching this video if you did production, but okay. So max redundant temperature difference between the two. Oh, you can analyze between the two. Okay. Anyway. As it heats up, it's going to try to achieve a temperature, and this is where this comes in. It's going to have 10 seconds of stable time at that temperature before it tells the printer it can keep going with the next command. So, the hysteresis is how much it will fluctuate up and down. So let's say you're printing at 200 degrees Celsius. So this is for this section right here. You're printing at 200 degrees Celsius, you're printing some PLA. The nozzle reaches 200 degrees Celsius. It has to be at 200 degrees or within a range of 3 degrees for a minimum of 10 seconds before the printer continues going. To temperature window. A lot of this stuff is actually pretty self-explanatory if you read the stuff right next to it, but we're not playing with that. I've never played with this. I've never had bad results by not playing with this, but if you really want to tighten this up, you really can. You can change that hysteresis to 2 degrees Celsius, and it will constantly turn the power supply on and off to try to keep that temperature at 200. or it could constantly give you errors because it's all fluctuating in and out of the window. So I just leave that alone. That's been pretty good. Heater minimum temperature. So again, I have 2 heaters. This is the minimum temperature it has to register, or else it will say that it is broken. So it has to reach a minimum temperature of 5 degrees. So if you have a broken thermistor and it's not reading a temperature, this is where you could kind of override it, but I don't know why you would do that. You want your thermistor to actually read a temperature. Otherwise, it's broken. If it doesn't read anything, it's broken. You should just change it before you burn your house down or somebody else's house down. But so minimum temperature, it's got to read, or otherwise it registers as broken. 5 degrees is good. They put it in there as 5. I'm good with that. Heater maximum temperature. This is for your extruders again. The maximum temperature your extruder can hit, you can hardware limit it right here. I have dual E3D, so I can probably reach like 300, but I actually don't print anything above 250 degrees yet. So I try to limit both mine to 250 just in case my kid comes up here and tries printing something and doesn't know what they're doing. My bed temperature also on my heated bed is, I don't think I've ever seen it reach above 105, but I've never printed above 100 on it. So I can literally put a pot of boiling water on there if I really wanted to. But yeah, I have never printed above 100 degrees, so I'm just going to limit it right to 100. My ABS prints have been working really well at lower temperatures, so I'm just going to leave a maximum of 100. I usually don't play with any of this stuff down here. I'm not going to the more advanced stuff. I just leave that alone. So PID auto tuning. Anytime you upload new firmware, you change your thermistor, you do anything with your hot end, you should always do a PID and get that set. But for right now, I'm just copying and updating my firmware. I'm going to go grab whatever my manufacturer used for a thermistor and copy over their settings. So I got a 22.59. This one's got a 22.2, so I'm going to change that one to 0.59. 1.52. A lot of this is just simple copy and paste. Find your original and just copy over the stuff. Usually the manufacturers tested 1 or 2 thermistors to figure out, actually they probably should have tested a bunch of them, to figure out what their value is, and they put it out there. So we're just going to use this. It doesn't really matter what the brand is, they just put it up here. Just fill in the blank. It doesn't matter. They have preset ones for the Ultimaker and for the Mendel and for the Maker Gear. I don't care. Just fill in the ones that are close to yours. If you don't know yours, you can leave the stock values that were here on here and run a PID auto tune anyway. I'm going to run one later after I upload the firmware and update these values, but for right now I'm going to give it a good starting point where it is. Again, same thing for the bed if you really want, if you have a heated bed. So we got 355, 665. Copy. Why does that not even look close? Oh, that's some weird ass values. So 355, I'm going to probably regret this later because that doesn't even make sense. And 480. Alright. Keep going. Again, they have, for some people on here, they have some predetermined settings. I'm just going to grab that section, change out the values I need to, and keep on going. So, prevent dangerous extrude. This should kind of be self-explanatory. You don't want it to extrude when the hot end's not on. and you don't want to extrude for no reason without it actually running a print, without, you don't want to sit there and be like, oh, well, I just typed in extrude 1,000 millimeters and I walked out of the room. No, that's going to prevent that from happening, and this line here is going to prevent it from extruding without actually being at temperature. So minimum temperature to extrude, that means the controller will not extrude unless it hits this temperature. So 170 degrees, you can kind of extrude PLA at 170, but at least the motor will, at least it'll be up, have some temperature on it before the extruder tries. So this is all it's for. It's not for printing, it's just stopping it from trying to extrude unless it's met a minimum temperature threshold. So this one's 170. Thermal runaway protection. There is so much math on this, it's not even funny. This is the instance where you don't want your hot ends to, you set it to 200, next thing you know your house is burned out because it kept going to 300 and 400 and some reached plasma and started a fusion core inside your room. This prevents that from happening. This uses the PID values up here and figures out if it's running away from you, if it's overreached, if it hasn't reached there or something. It limits so it doesn't go crazy. And turn it on for both your hot end and your bed. If you don't have a bed, up here up top, where it says bed sensor, you can just change that to a 0. If you don't have a second extruder, just leave that as a 0. But if you turn that off, it won't show up. You can still leave the rest of the values there. You don't need to change this one. You don't need to change this one. If you change this one to a 0, none of these are valid, because 0 is not used. And it automatically figures out that you're not using it. So, Endstops. This is fun. So again, you want to grab whatever your manufacturer uses and turn them on. So Endstop pull-ups. This means that when you turn them on, whenever your Endstop hits the max Endstop, if you have maxes, usually most people only have minimum, so don't even bother with these unless you absolutely want to turn them on the board for later. They don't have to be on, but this part right here, when it hits minimum, it's going to pull up and tap that again. So it's just a real, if you've seen a 3D printer work and it goes to home position or it goes to whatever the minimum position is on that axis, it's going to tap that end stop, back away a little bit, and then tap it again just to make sure it did tap it. That's what that does. That's the pull-up. It's going to pull up once, tap it again. So if you happen to have your end stops inverted, why wouldn't you just comment it there if it's max? I don't know why. This makes no sense. But we're going to keep going. So according to my manufacturer, X, Y, and Z end stops are inverted. They're all true. So, seeing as mine are minimums, true, next, true, and true. I don't have a probe, and the maxes I don't have, so I can actually disable minimum end stops or maximum end stops right there on that line. So I don't need to worry about that. You can also set up a secondary end stop for a probe if you really want to. Features available right there. And you have to uncomment this one, so on and so forth. So I'm going to keep going down the list and keep turning things on that the manufacturer had on for me. Okay. So this doesn't turn off. When the printer is not being used, it doesn't turn off the motors. So you finish a print, it won't turn the motors off right away at all. And same thing for the extruder, and that covers that section. So if you really want to, when it's completely done, you can actually have it turn on by changing these to true. You can have it turn off the motors completely, your X, Y, and Z. And if you've got like a Delta printer, that's probably not a good thing because it'll probably come crashing down. I'm not 100% sure. In my case, my Z-axes are inverted, and if I have enough weight on there, I guess it could theoretically start rolling down. If your machine, when it's completely powered off, if there's an axis that moves to one side or another freely, that's exactly what's going to happen. It's like almost as if you shut down the machine completely. But in this case, the machine will still be on, but those motors will be off. Same incident. So if you have, and this section covers the direction. If you decide to throw this all on there, and all of a sudden your Z is moving in the opposite direction of where it should be, this is where you change it. So for me, my original factory settings are invert X. So the only one that's inverted is the X and the extruders. So X would be true. I don't know why it does that. This one would be false. And you can test this as you go along. You just flash the firmware, and if your motor moves in the opposite direction of where it should be, you change it to a true or to a false, and you flash it again. So my manufacturer says XYZ, and X is the only one that's true, but I assembled my machine upside down. Well, not the whole machine, just the Z-axes, because I wanted the motors to stay away from the parts. So automatically, I'm going to put this one in as, well, fat finger syndrome's kicking in, as true. Again, they tell me that the extruders are going to move in one direction instead of the other, so that's a true. And this guy right here is also going to be a true for my second extruder, so they both extrude in the same direction that they should. Alright, homing direction. If you remember your math class, or you don't, look up Cartesian coordinate system, and this is your XYZ origin. If you want your machine, or if your machine's supposed to home to the 0 coordinate system of your XYZ axis, this is how you set it. If it goes the other way, if you want to change it to go to the other side, you make that a plus, so it goes away from home. That's where your end stop is. But if your end stop is at, to where your bed's in a position of home, this is where you leave it. My manufacturer put it so that the nozzle, when it's homed, is directly at 0, 0, 0. 0x, 0y, and 0z. You could put up the... This is kind of like a redundancy from over here, because you could tell it that your Z max is, that your Y, for example, is on the max side, and then you wouldn't have to worry about this side. But that's weird. Well, I guess it comes in with the bed positions and stuff. So, define minimum software end stops. So this means once it hits the end stops, it won't go any further than the end stops. On some machines, you could have an optical end stop, and you can still continue on further. And this is also the same thing for your maxes. And this is how you set your max position. So with these all being negatives for being minimums, so obviously your minimums are all going to be 0, because that's your starting point. My machine, I have a rigid bot big, so my max sizes are right here. I can actually just copy and paste this whole section, but I could go here. Because the firmware is older, I don't want to actually copy and paste anything. So I'm going to change this. Wait, I just got fat finger syndrome again. And so that's the size of my machine. That's the size of my single extruder big, which doesn't help me when I have the dual extruder. And I guess they didn't get very definitive with that. Well, I went ahead and ordered Peter Stoneham's dual extruder kit anyway, and I already tweaked mine in. So I actually know exactly what the size of my machine is. I spent countless hours trying to figure that out. Yes, I already pre-edited another one. I just want to show you guys a fresh one. So, if you have a big and you have Peter Stoneham's dual extruder kit for your rigid bot, these are the actual settings. This will literally it's about 2 millimeters away from the Z screw right here on the X position. In the Z position, on the Y position, it's less than 5 millimeters away from completely slamming through the other end of your machine. It is the maximum I could actually fit without it actually touching anything, as long as my end stops were at their absolute bare minimum. So now we set our maximum position for our machine. Gonna go ahead and filament run out. Well, we're not going to turn the section on. All you have to do is uncomment that. I don't have a filament run out sensor. I don't plan on having one anytime soon. And again, this is just a simple one. Manual bed leveling. Again, not something we're doing. Bed auto leveling. This gets really interesting. I'm actually working on this at the moment, but I'm not going to explain that here. But if you want to turn it on, all you have to do is just uncomment these two lines and then define the grid position right here on these 4 values. If you want to use a square grid position, you can use these this kind of. So you can use the 3-point system if you really want right here. Like I said, I'm not going to cover that in this section. But if you did, here's where you put your offset for your probe. So with Pete's, it's 52 millimeters to the right. It is 52 millimeters behind. And then you set this later on by touching off the bed and all that other happy horse stuff. Yeah, like I said, not being covered, and there's plenty of other videos out there that have already covered it. In fact, I believe Thomas, and I'm going to butcher his last name, Thomas Salamander. Thomas Salamander, why not? I'll just nickname him. He's got a video on how it actually works and how to set it up. His videos are phenomenal. You guys should really watch his stuff as you get more advanced. This sets how much to pick up the machine as it moves around. Again, I'm not going to bother with any of this. We're not covering it. Skip, 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 skip. Skip, skip, skip. Skip, 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 skip. Alright, homing feed rates. Skip. So here's a section we need. Axis step per unit. If you know the number of gears and the number of teeth your pulleys run, if you know the stepper or the micro stepping that you're using, this is where it all goes into. You can calculate it all out. My rigid bot stock, there's its stock values. I can just highlight that section right there and copy and paste it, and that would pretty much get me covered. However, I have since upgraded to 20-tooth gears or belts, 20-tooth belts, whatever. So I know that that one's an 80, and I've changed everything to 1/16 micro stepping, so that one's going to be exactly 80 steps also. My z-axis was already at 1/16th, so I left that one at the stock setting of 1600. I didn't change anything on the z. And because I shrunk up the gear for this guy, which is running at an eighth, so that's running at an eighth. So because I stepped it to 1/16, I should just automatically double that. That should be 107. 07. If you change the gear that's on your extruder, this is also where you might want to start calculating. But you want to do a PID auto tune, and you want to do a extrusion measurement after you're done. You can either do a cold one or a hot one. I recommend the cold one, that way it repeats all the time. But you can cold calibrate your extruder after this. This just gets you at least in the ballpark. Maximum feed rates for each one of these axes, X, Y, Z in the extruder. If you know your motors, you know the max that they can handle, or your manufacturer. According to RigidBot, we can do, or yeah, 500, 500, 3. 500, 500, 3, and 25. So this is how many turns it's going to allow it to do. So 80 for how many steps per millimeter. This one's only going to allow it to move 500 millimeters a second because that's really fast. Acceleration, that's how fast these motors can try to get up to speed. So if you think about it car-wise, this is the speed limit it can run. This is how fast it can get to that speed limit. So according to them, 110,000. So if you got a better machine, you can probably do faster. If you tweaked your machine, you can probably do better. If you run different bearings, you can probably do better. So as you upgrade your machine, you can start playing with these values if you really want. Default acceleration. This is new in comparison to the old way they used to do this. They used to just do 800, you know, real simple numbers over here. They added a third way of looking at it. So default acceleration for any printing move, this is as fast as it can move just for printing. So according to RigidBot, I believe it was a 600 just now. Yep. How fast it can retract. Again, this is your acceleration to get there. It will only retract at 25 millimeters a second. But how fast can I get to those 25 millimeters a second? I'm going to crank this up, to be honest with you. I think they were a little bit, well, actually they didn't have one. Actually they did 1,000. I'll leave it at 1,000. Travel acceleration. So as it's moving around and not printing, how fast can it accelerate? Well, I'm going to leave it at a conservative 600. That's the new one right there. That's the one that was never defined before. So think about it. I'm just going to copy their regular acceleration for printing. And if I really want to, I can tweak it up from there. X, Y jerk, Z jerk, and E jerk. The best way to explain jerk is corner cutting. As your printer goes across, it will try to cut a corner. It will never actually reach the full 90-degree corner. It will cut that corner if it can, because you might not need it. So this is what defines how big of a corner it can cut. By default, they're telling my machine it can do 5, 5, and 5. So the best way to explain it is really just corner cutting. When it's going down, like if you're looking at my mouse cursor, it's going down a line, going down a line, going down a line, following this line right here. Then it wants to cut this corner to go to the 90-degree angle. It will never actually really do the 90-degree angle. It will, this number will tell it how soon to start working on the other axis, because it will actually engage the other axis before this one comes to a full stop. It really comes into play for speed. The faster you print, the more this corner it's going to cut off. The slower you print, the less defined, the tighter that corner is going to be. So it ends up being a balancing game later on as you're trying to tweak stuff between this and this. You're constantly going to be playing between the two. As you turn off your max acceleration, actually your feed rates. As you turn up your feed rates, this is going to get worse. So you're going to shrink these numbers down. As you print slower, it becomes a very fine balancing act. If you want to figure out what this is, or a different way of explaining it, if you look up machining and you look up G05.1, that will kind of start giving you a high-speed corner cutting view of the machining world, and that's exactly how they implemented it into 3D printing, is the jerk settings. So I'm copying my original ones from my manufacturer, leaving it there. Going to keep going. Custom M codes. If you manufacture a machine to sell to other people, so this is why you're watching the videos, because you're doing firmware for your own machines that you're selling to your buddies or to your, I don't know, your corner guy. Maybe you sit on the corner and sell 3D printers out of your jacket. I don't know. So what this does is, if you don't want somebody playing with any settings, you don't turn this on, this right here. But seeing as I'm a home user, and this is why you're watching it probably, all I do is define EEPROM settings. That turns this stuff on. And we're going to cover that a little bit later. But these are probably some of the most important commands on here, because they come in so handy so you don't have to constantly be flashing your firmware. So, for example, M500 right here says storage parameters in EEPROM. So let's say I go to print my calibration cube, or I do a cold calibrate my extruder, and I end up finding out that my cold calibrated extruder should be running at like 107.96, or really badly off, and I completely screwed it up, and I should be running somewhere around 152.32. I could just edit it like I just did and then reflash the firmware, or I could literally come down here, turn on the EEPROM settings, and then from the command console and whatever software I'm using to communicate with the printer, I could set those new step values and then type in M500, and it will automatically store it right to the firmware that is on the controller at the time. A lot of people don't like doing it that way. They like writing it in the firm right here, the way I'm showing you right now, so that they always have a backed up copy of their firmware. Others just want to get the printer up and running, or both. It doesn't matter. If you turn this line on, these commands all work. 500 to store it, 501 to read it, and 502 to go back to whatever. You can store it temporarily, you can store it permanently. So if I go in there and I type this all in, and I use the M command to turn it on and change it to 150 on the extruder, I can type in M500. If this isn't turned on, it won't store it. If I type in M503 so that it tells me what is currently running, it's going to display my new settings of 80, 80, 1600, and 150. But if I type in M501, it automatically reads right from the EEPROM my original ones of my value of 107 originally, and pulls it and implements it right into the firmware and starts running again. So basically it's a giant reset button. But I want to be able to adjust on the fly, and I'm going to need to, so I'm going to turn that on. Keep going. Your preheats for your PLA and your ABS, you can actually pre-program it. So if you're preheating PLA, if you have an LCD, you can just scroll, pick preheat PLA, and it'll automatically start preheating these temperatures. Same thing with ABS. LCD section. If you have an LCD, this is where you start defining it. And you can go through. There's a huge list of these. The most common one, or what I believe to be one of the best ones out there for the price, is this guy right here. It's a full screen LCD. It is great. It is cheap. You usually get these for about $13 US to 17 US dollars shipped to you. And it's got a SD card slot on it, which to turn that on, you need to uncomment this instead of yelling at everybody for 2 weeks that your SD card doesn't work. So I will show you how to turn on the LCD, but if you don't have one, don't worry about it. So I turned on my SD card support that my LCD has. I'm going to go down here and I'm going to turn on my LCD. There we go. Now right there it tells me make sure I get this library installed. I'm going to copy that only because I'm going to be looking for it later. That covers the LCD. Fans. You can change the scale of the fan in case the LCD is not reading it right, or you don't want it to read right. So if you want your fan, let's say your fan runs at 255, but you want to run it at half scale the whole entire time, you can change that here if you really want to. I don't bother. Let it run the way it is. Servos, I'm not doing anything that fancy. Filament sensor, again, not doing anything like that. So as it sits right now, this firmware is modified for my mostly stock machine. And that's where I'm going to leave it. There's all the values I changed out. Date. I'm going to hit save. It's going to automatically, I'm going to close it. I don't need to play with this. This is the stock one. I'm going to close this. And if I go back to configuration H, and again open it in Notepad, you'll see that my values have been saved. There it is. Scroll down. There's my date and name. Close. Now this guy won't show it because it's been active the whole entire time. So I'm actually going to close out Arduino, and I'm going to find the marlin.ino file and double click it. And it'll sit here and load the Arduino flasher. And let's make this larger. Alright. So if I check my configuration H file, there it is. And again, like I said, you could edit it all in here. You don't have to edit it in Notepad++. That's just the way I like to do it because it's so much easier to be able to tell. Like, the define shows up as one color, the custom machine shows up as another, and then the comment that I want it to display shows up as another color. But when I go to over here, like some of these colors are not necessarily easy to tell from one another. So you could probably get lost. But again, it's available here. And the only file, like I said, you should be touching should probably be your configuration H file. The rest of it, unless you get more advanced, you might touch some things, but you really shouldn't be playing outside of configuration H. We are going to go find that library that I need for my LCD. So I'm going to include library, and they've so much have improved this. So all you do is close that, go Tools, go Sketch, include library, manage library, and then you can search for it. And again, what I copied and pasted earlier, oh, apparently it doesn't want to paste. Oh, great. Oh, it did. There you go. I just happen to have it installed already, but you can, it's unbelievable how much easier they made this in their new versions. But if you want to like install one, all you can do is click on the one you want and hit install if you need it. Like I said, I need this specific library for my LCD controller, and it even tells you a library for monochrome TFTs and OLED controllers and screens. And all I do click, install would be right here, and it would automatically install it. So I have that. Close. Actually should have added that line right to there. Scroll downward. because I don't want to open this in Notepad right now. Because I believe all I need to do is servos. Where's the LCD? This is so much easier in Notepad. I can't read. There we go. No, maybe I'll turn it on. The last time I did it, it actually added it straight to the Marlin file and called it out. Okay. So I don't have my Rainbow plugged in yet, but I can actually test to make sure that I didn't screw anything up. All I got to do is hit verify. And it's going to sit there and it's going to compile. And if you actually watch if you have a way to watch your CPU cores, which I want to bring this in, you can actually sit there and, I mean, most of this is my recording. You can watch it actually happen in real live time, compiling the sketch, making sure that there's no issues, nothing broken, nothing wrong. Don't worry, this takes a minute. On my Core 2 Duo laptop that I sacrificed for my printer, this actually takes quite a few minutes. So just take your time, relax, don't worry about it. It'll get done one way or another. And you should have a success. Any errors that show up are actually going to show up in this black box down here. So if you did do a typo or put in something you weren't supposed to, you can pretty much figure out what you screwed up just by looking down here. Ooh, and I just remembered I screwed something up. Wait, what? Heater 1 pin not defined for this board. Should have probably tested this out. Oh. Did I do something wrong? Probably put in the wrong board. Again, great idea of compiling it before you actually try to upload it. Ah, 2 extruders. And I'm telling it an extruder, fan, and bed. Nice. Great. Great job by me. So, pins H. Open. Oh. Ah, screw it. I'm going to leave it. And I'm looking for E, E, B. Ramps E, B. It's right in front of my face, isn't it? Copy. Close. I'm going to go ramps. Paste. And verify. Bet you it goes away now. If it doesn't, I'm going to stop recording, smash this thing with a hammer, and fix it, and come back and continue recording. And by hammer, I mean I'm going to hit my head up against the wall. While that's going on, let me go grab a USB cable. Which apparently I never have any around when I need them. Alright, here's one. There we go. This actually takes longer on my 8-core machine than it does on my Core 2 Duo. You get real fancy with some of this stuff. You can actually, if you do it for somebody else's machine, you can sit there and label their machine. Sit there and go, my friend Bob. Kind of fancy. It actually doesn't do anything while you're actually compiling it. I hope not. There's no undo button in this either. That's why I don't like it. Notepad++, I'm telling you, that is the greatest thing ever. Whoever invented that, I hope you're a millionaire. And if you're not, I'm sorry. And we wait. get bored waiting. Doody doody. I wish I had I should have prepared and have the Jeopardy theme sound playing in the background while I was doing this. That would be awesome. But no, I didn't do that. Why? Because I didn't think that far ahead. Still thinking. Oh, you're gonna get hit with a stick later. This doesn't finish soon. I'm gonna shut the computer down for a whole week. Teach it a lesson. Come on. I should probably pause the video and edit this out, but I'm probably too lazy for that. So, after your 2-hour video, aha. This is the one mistake I actually expected to find. So, it compiled, but it got to its first mistake. In fact, it's still compiling. It got to its first mistake. This is the one I actually left out and didn't correct on purpose when I started recompiling. Aha. So, it is missing the library. So if we click on configuration H, which is where we are, my friend Bob is now added. We're going to go edit, no, sketch, include library. We're going to include this library. That will add it to the top of any file that you have open at the moment. The last time I did this, I accidentally left it on the top of this Marlin section, and boy, did a few people yell at me. But there we go. We included it. It's now into the configuration H file. And if I hit verify, it goes through and it's going to build this whole entire sketch. This whole entire firmware without an issue. Which means we get to wait for a third time and watch me waste time. Yay, go get some coffee. You're gonna need it. My recommendation for you guys is play this thing at like 1.2 or 1.5 speed on YouTube. You can right click and select the speed to play it at, so you can skip over my bantering and useless rants or useless information that has nothing to do with you. Come on, you can do it. Gotta get a nitrous button for this computer. It probably would go a lot faster if I wasn't video capturing. I'm sure that's chewing up a lot of the processing. In fact, I can guarantee you that's chewing up tons of processing. Because I'm trying to show off and record at 60 frames a second. Trying to. There you go. Done compiling. Completely built the firmware without an issue. So right now, you can grab your little controller board, which, there's an Arduino. Plug it in. So now we need to tell it where things are occurring. So tools, and we're going to tell it what kind of board it is. Arduino Mega or Mega 2560, which is what a lot of the aftermarket controllers are based on. If you got a Duo or an Uno or some of the other stuff, I don't. That's what I'm using. We're also going to figure out which COM port it's on, and if you're using Windows, you're going to go to your Start menu, to your devices and printers. I know my Start menu is on my other screen. So there's my devices and printers. And we're going to wait, and now you can see everything I have inside my house. And right here is going to be my Arduino. So I'm COM31, because apparently I've unplugged it so many times it changed comms. Tools, port. Usually, believe it or not, it will actually only allow you to flash on the right one. But you can pick, make sure you specify your controller, which as you plug in your board, it's going to limit you to what it is. And make sure you specify your port. And then literally, if you already pre-compiled it, you checked it, you can just upload, and it will upload this firmware image right to your controller. It will actually go through the whole entire process again of verifying it, and then it will upload it to the controller, and then you will be all set. There you go. Your board is up and running. Again, simple, long-winded, but there you go. That's how you modify your configuration H, or modify your firmware. And like I said, feel free to play around with some of the stuff. Always keep an original copy handy, like I did earlier. So I got the RC folder is the one I'm playing with, and the original is just there. That way if I screw anything up really bad and it doesn't compile, I can always grab an original, drop that file in, and start editing again. And like I said, you should only be really playing around with your configuration H file, or the configuration H tab if you want to do it here. There's no real reason, unless you're going really custom, to do anything else. If you have like a SainSmart 2-in-1 board or the MKS board, you probably will need to play around with the pins file to get the assignments correct, because they completely butchered some of those pin assignments, especially that SainSmart board. That 2-in-1 board, they really butchered the pin assignments when it comes to the heated bed and the 2 extruders. And that's when you would actually start playing with the pins. If you want to change between, all you do is click on the top tabs to change in between. You could also, if it doesn't show up enough, hit the down menu and it shows you all the files that are there. If you want to be editing inside of there, and there's a lot of files. If you don't want to edit inside of there, you can just grab the file that you need to edit, right click, open with, choose program, blah blah blah, or edit with Notepad++. Don't really play with these files. You could really screw some stuff up unless you know what you're doing. And there you go. Hope you guys enjoyed this. Hope it's not too long-winded, and hope you learned something. Everybody have a nice day.